Hello everyone. Today we're going to discuss about zeros, multiplicity, and its effects on the graph. Let's begin. So this is our first example, and we're going to go ahead and set this to 0 in order for us to use the zero product property in solving for the zeros of this factored form function. Now split the functions for space purposes. Now set each factor equal to 0 and then begin solving for x. For the first one, we don't have anything to solve anymore. So this is x equals 0. So that is your first 0 of the function. But for this one, we need to isolate the x. Move the positive 5 to the other side. Do not forget that the sign will change if it moves from left to right. Bring down the 2x and divide by 2. And so your 0 for this factor is negative 5 out of 2 or negative 2.5. All right, now these are the zeros of the function over here, and let's discuss the multiplicity. So multiplicity is the exponent of the factors. So the exponent over here, as you can see, is not shown, so it's understood to be 1. Therefore, the multiplicity for this factor is a 1. Here, the exponent of this factor is a 2, so the multiplicity here is a 2. And now we're going to discuss about the effects of this multiplicity in our graph. When your multiplicity is an odd number, it's going to cross the x-axis. So your graph will cross the x-axis through that 0. Okay. When your multiplicity is an even number, which in this case is, it's going to bounce on the x-axis. Also, sometimes they call it tangent to the x-axis, and we're going to observe that using decimals. All right, so we found our zeros, which are x equals 0 over here, and x equals negative 2.5. So on here, where the multiplicity of this 0 is an odd number, which is a 1, notice that the graph had crossed the x-axis at that point. However, here, the multiplicity of the 0 is an even number, which is why your graph had bounced. Example number 2. We will set this equal to 0 and then solve for the zeros of this function using the zero product property. Okay, we will make some space in order for us to solve for the zeros of this function. All right, so the first thing you're going to do is to set all your factors equal to 0. All right, for the first one, your x is already equal to 0, nothing to solve anymore. For the second one, we're going to move the negative 4 to the other side of your equation, and so that negative 4 turns to positive 4. And so your x is equal to 4. Here we're going to solve for x, and we are going to move that constant to the other side, making x equal to negative 1. Now that we have found all our zeros, our next thing that we need to identify are the multiplicities. So for the first one, the power of this factor is 2. Therefore, the multiplicity is 2. For this factor, our multiplicity is 3. And for here, the power is not shown, and we all know that if it's not shown, it is a 1. Therefore, the multiplicity here is a 1. So let's review real quick the effects of these multiplicities in our graph. So if it's odd, it's going to cross the x-axis. If it's even, it's going to bounce. So this is an even number, so we're expecting that even multiplicity to bounce at that 0. Here, we're expecting this to cross at the 0 of 4, and this we're expecting it to cross at the 0 of negative 1. Examine the graph. So x equals negative 1. We have a multiplicity of 1. And you can see here that it crossed the x-axis at that 0. Here, we have our multiplicity of 2, which is why it bounced. And here, we have multiplicity of 3, which is an odd multiplicity, making your graph cross the x-axis. Okay, example number 3. As you can see, it's not yet fully factored. So we're going to have to factor this out using the greatest common factor. All right, so as you can see, x to the third plus 2x squared, they have a common factor. They have the greatest common factor as x squared. And so I'm going to factor this out from both these terms. Okay, so if I factor out x squared from x to the third, it's going to result to x. And if I factor out x squared from 2x squared, the result is 2. So now that this is fully factored, we can already set this equal to 0, solve for the zeros, and we can already identify that the multiplicity for this factor is 2, and that here the multiplicity isn't shown again, so it's a 1. Set both factors equal to 0, and in this case, we already found the 0. X is equal to 0. Here, we're going to um, do the inverse of positive 2. Therefore, this is going to be a negative 2 on the other side. So here, the multiplicity is 2, while for here, the multiplicity is 1. At this 0, your graph will bounce, and at this 0, your graph will cross. Make sure to go back and label all these zeros as well, and the effect of the multiplicity to that graph. And please do the same thing for example number 1. Now for example number 3, let's go ahead and examine the effects of this multiplicity on the function. So for x to the third plus 2x squared, we found these zeros. And on the x equals 0, we found the multiplicity of 2, which is the effect of that is that your graph will bounce. On here, the multiplicity is a 1, and that's why your graph had crossed this 0. So this is our last and final example. As you can see, it is not factored completely, so we'll have to factor this out using the greatest common factor. Notice that for all the terms, the biggest common factor that I can factor out from all of the 3 terms is x to the third. Turning this to be x squared now, and then 4x to the fourth divide by x to the third will give you 4x. Then for our last term, 4x to the third divide by x to the third will give you a 4. Notice that for this trinomial, it can still be factored out. So we are going to go further. Copy down x to the third. And this now are the resulting factored form of x squared plus 4x plus 4. So now this is the fully factored form, which has the multiplicity of 3 for x. And for x plus 2, it has a multiplicity of 2. Let us now solve for the zeros. Set both factors equal to 0 and solve for x. In this case, your x is already equal to 0. So 0 is your x-intercept or is your 0 of your function. On the other one, you're going to have to subtract 2 on both sides or do the shortcut of putting negative 2 to the other side and changing the sign, which results to x equals negative 2. So these are your 2 zeros. And now let's identify the multiplicity and write them down. Your multiplicity here is 3, and here your multiplicity is 2. Your graph at this 0 is going to cross, and your graph at this 0 will bounce. Let us examine the graph. Okay, so this is the graph and how it looks like. And at this point, if you can see it, the multiplicity is 3, which is why your graph is crossing the x-axis. On here, your multiplicity is 2, and your graph is bouncing on that point. And so that is it for our lesson on zeros, multiplicity, and its effects on the graph. I hope that you have learned a lot today. Thank you.